If we want to write the number 3 as a sum of positive integers, we have the following choices. We can just write it as 3, or as 2 plus 1, or as 1 plus 1 plus 1. So these are the partitions of 3. And we usually write them like this. The first one is just 3, and then we write them as non-increasing sequence of numbers. So the partition 2 plus 1 we write as this sequence 2, 1 here. And the last one is this one. Let's do the same for 4. The partitions of 4, that's, well, 4. And then we have 3 plus 1. We also have 2 plus 2, 2 plus 1 plus 1, and 1 plus 1 plus 1. Graphically, we represent these partitions in terms of so-called Young diagrams. And we just write rows with boxes, and we write as many boxes in a row as this number here. So this is the Young diagram for this first partition here, 3 boxes. Now the second one has 2 boxes in the first row and 1 box in the second row. And the last one has 1 box in first, second and third row each. Let's do this for the partitions of 4 as well, which will give Young diagrams of 4 boxes. And these are this 1 row diagram here with just 4 boxes. And then we can have this one here, 3 boxes on the first row, 1 box on the second. And here we have 2 boxes and 2 boxes. And this one here, 2, 1, 1 boxes, and then this 1 column diagram with just 4 boxes. And we can order these diagrams or partitions by comparing the length of the first row, and if it's longer, then we say that the diagram is greater than the other one. If they have the same length, then we compare the length of the second row and so on. So here this one is greater than this because we have a row of length 4 and a row of length 3 here. Same argument here in the next step. Since we have row of length 3 and a row of length 2 here. Here again, the one on the left is greater than the one on the right. But here we have length 2 and length 2. So we have to go to the second row and see that we have length 2 here and length 1 here. And then for the last one, we have the same argument as before. First row is longer here than here.